Okay, so let's just go on. And now what I just did is like make another folder called post processor to put the second part of the video, okay? In this folder, I added like everything required for the Polytechnic Tutorial Solver, which are many files and folders, okay? Here there's a README file that you can read to get more information about that, but we're gonna go just directly to what we require right now. Okay, so let's first just open this script 00. This script is just gonna build us another file, another .mat file, but modifying the original one that we created. No, so just in this folder, put your WEPA. In our case, it's the 1020. This is the name that I just put over here. And that's basically it. We have to check all the parameters and change the ones that are required. For instance, the radius, the height, the draft, and the mass. I put the ones from my project, my problem. Here there are many flags that we can turn on or turn off. You should just go to the simulating model and check this simulating model over here that is in models and parameters. Then check what flag is it, that it's usually represented with a gain. Then here there are things related to the simulator, even though this information is also on another file that we're going to see right now. Things related to the geometry, well, these are the same data that I just put it here. Things related to the inertia, that is the same values that we put on the ANSYS with that calculator online solver. And here things related to the PTO. This is not so important right now because as we're going to do only the modeling of one kind of wave, we're going to change also these parameters later. But yeah, you could change all these parameters right here and just run it. When we run it, you will check that here in models and parameters, there's going to appear another file. Okay, let's run that. Okay, here this file is loaded. So once we've done that, we close here and we open the next file, which is this one, 01. Okay, here in the second file, we have to add this file that we just created over here. Also more parameters related to the simulation, but we don't have to do nothing about that, okay? Just put your name file and run. Okay, in fact, what this is doing is generating here all these files. Okay, 36 files. Yeah, the 36 number is because of this number over here. If I delete this and I run it again, it will put the folders again. So we're done with that, and now what we have to do is go for the last file, which is the debug. As I said before, this file is gonna be useful only for one kind of wave, but if we wanted to use more waves, just run the multitask one, but this one takes too much time. In fact, for simulating it right now. So as I told you before, here we're changing the K of the PTO, the beta of the PTO, etc. No? And here's a wave ID. It's gonna use the input wave number 9 from the waves that we have here, the wave models. These many waves, 224 waves. Okay. So how did I choose the wave number? So I made another script which is called plot waves. Here I put the minimum period that I want, the maximum period that I want, the height, the minimum, and the maximum. Okay, I just put these values because are equivalent to the ones that I used on the WEC simulator. So I just run this, and I see here's the plot of the waves, the one that I chose, or the number one, but this is not important at the moment. But this is important. So these are the indexes of the waves that are in these ranges over here. This is the period, and this is the height. Okay, so in my case, I'm interested on number 9 because it has a height similar to to the one that we have put in the WEC sim, which is 03, and also the period. In the WEC sim it would be 7, in this case is 7.3. So that's why I chose here number 9. For the rest, again, we don't have to do nothing about that. This is gonna launch a simulating model in concrete, this one over here, okay, and it's gonna plot the data. It's gonna make a here in the the book. If we put here a 3, for instance, we have to also put here a 3, and we can run it. We're gonna see like it just build the inmat 0003, and it's also gonna build the outmat 0003. Okay. Okay, so again, we have a lot of information using this solver, elongation of the mooring line, but this elongation has also things to do with the swords, because this is 3 degrees of freedom. Maybe the one that we're more interested right now is the heave, is the one that is similar to what we've seen before. And we could plot just much more information using this tool, because there are things that are commented. If we just go here, we can uncomment all these parameters and just keep looking for information. Now here, there's something that should be changed, because in our case, we don't have a motor shaft, we just wanted the force, okay? So this is getting a torque, Newton meter, but we just have to divide this into the input shaft that we have, that should be here. It would be the pulley, yeah, the pulley or the radius of the shaft. We should check it on the simulating model, but we have to apply one of these transformations. For the rest, we can see the velocity, acceleration, the same like in the WEC sim. We can see also the torque, and also the pitch, heave, and torque in meters. Okay, so this is everything about that. Yeah, this is everything about that. What we're gonna do now is I'm gonna check what information is important for me for this project, just to compare this information and the information we got from the WEC sim, and check which one is better, or which one we can trust. I must say that in the case of the pretended Euclidean solution, so this solution, we don't have any plot, we don't have any video, so that's why in some cases it's more visual, the WEC sim, but anyway, this information can also be reliable, okay? So that's it. The results are going to be set on the thesis, and the comparison between this part and the WEC sim, of course, with comments and conclusions. Okay, so I just edited the video and I saw that I wanted to mention something else. I just wanted to say that after doing the book, after doing this script, running the script, we can check if the results that we got have been simulated with the data that we had at the beginning. No, it's here in the 4.8 the book. We just created those 2 files. So let's check the input file that went to the Simulink. Okay. We just put in mat, yeah, here there's all this information. Let's go for inmat.par. Okay, here the first thing we want to check is that the wave is the wave we wanted. Okay, so wave, so it's this one, yeah, it's wave number 9, so we just simulated with the wave that we wanted. That was good. Something else that we have to check is the geometry, for instance. Geometry. Okay, this is also the data that we had at the beginning, all the data that we edited, so it's also good. Let's keep going. If we go for the hull, yeah, here it's more difficult to check it, but I'm gonna check it in anyway. FDA, hydrodynamics. So let's check that the hydrodynamics are the same that we got from MATLAB, no? From ANSYS Aqua. So if we plot that, let's check A parameter. Okay, the last one we can see here 19957. So if we load this file over here, the 1020 is ours. Let's put a name to this. So it would be A equal to this A dot hull dot FDA dot hydrodynamic dot A. Okay, so it's the same. Okay, so the data that has been the input for our simulating model, it's just the same that we had on our math file. So this is just a check that I wanted to do. That has to be done in order to check that if we change files or whatever, that the process from this file, the 00 to 01 to 01A, has been done properly. And that's basically it.